Hey everyone, I'm Dan. I'm here to talk about modernizing legacy IT systems. First, why modernize? Look, we've got some IT system, LDS in our case, was designed 20 years ago, sure, but it works, and it's been working for a long time. We have a lot of tools that are that old or much older. Why do we need to modernize? The world is changing, it's evolving, and it's changing faster than it's ever changed before. And it's incredibly competitive on an international scale. It's our responsibility to find cost-effective ways to do our jobs more efficiently. Fundamentally, our goal is to get more operational availability out of a fixed fleet of assets. Same problem you'd find at an airline or at a fleet of taxi cabs. Now, we could just buy more assets, but at a cost of a few billion a hull, we'd like to avoid that option. Designing the platform for ease of maintenance is another good choice. We've already pursued that with great effectiveness. Additionally, we can build facilities that better support the mission. Again, this is an option that we have considered and are pursuing. The ability to ensure that the configuration and capability of our buildings meets the needs of the workforce. Doing the same, ensuring that our software, our IT tools, are configured and capable to meet the needs of a future workforce is the next obvious step. At its core, the delivered capability that we need isn't a static target, like building a building that you can just use for 20 or 50 or 100 years without making significant changes. We need to build tools that evolve as the user's needs change over time. Now, LDS, our legacy IT system, has been delivering capability across the enterprise for decades. But it is not without problems. First, deployments. Typically, deployments require a team of engineers to fly out to the site to deliver and integrate and test and train for every update. Because that's expensive, we don't do it very often, so the frequency of updates is low. But with infrequent updates, we try to optimize that by squeezing as much change as possible into any given update. Now, change is risk. Every single time we make a change, there's risk that it will break things. And the bigger the change, the more risk that it will break some adjacent process or some integration with an adjacent tool, or that it will simply be unusable for the users. Second is reliability. We have a single server running the application and the data, living behind a single gateway, which is basically one long chain of single point failures. If any single point in the chain fails, the whole system is down until we can fix it. The data is all stored in one spot. If we lose that hard drive, it's all gone until we can restore it from an offsite backup, assuming that we're maintaining those. Security is the final problem. Our approach is problematic at best. This solution met the requirements when it was initially designed, but technology has changed a lot in the last 20 years, and there are new directives that we need to come into compliance with. Finding a way to modernize in such a way that we can improve security, reliability, and the efficiency of our workforce will be a cornerstone of our success in coming decades. What if there was a way to build a space where developers and users can access the same tool, so developers can provide routine updates, small updates with little risk of breaking things? What if there was a way to have 99% uptime? What if there was a way to guarantee that we can meet the security directives of today? What if it worked in our current environment, which is admittedly a very slow network? All of this is possible. Next up, we're going to talk about distributed platform independent applications.